Hello, everyone, and welcome back to our next sessions during Big Data Days. In this next session, we're going to have a very interesting session, which is very close to my heart and which is all around open source. It's a great pleasure to introduce to you Mr. William Guo from the Apache Software Foundation, which I'm pretty sure most of us know. And Mr. William is presenting from China today. He's an Apache Software Foundation member, Apache's incubator mentor, and he has successfully held important positions in big data parties in IBM and Teradata. And he has made several contributions to the frontier research of big data. He has also participated in several technical communities at the same time, such as Presto, Alaxio, HBase, and he was the founder of the ClickHouse Chinese community. Today, William is going to take us on a journey to talk about modern EtLT and orchestration architectures in DataOps, which I personally think is going to be a wonderful session. Mr. William, it's a great pleasure to welcome you to Big Data Days.
Yeah, hello. Thank you. Thank you. Thank you, everyone, to join my session. So shall I start my session?
Absolutely. You're ready to go.
Okay. Thank you, everyone. And thank you for the host. And today I want to share some experience on modern EtLT and orchestration architecture in DataOps. And just the host introduced me. I'm William, and I'm a Apache Software Foundation member, and I have more than 20 years of big data experience. And today I want to share some experience on DataOps. First, I want to introduce you to the new architecture of EtLT. And then I will want to introduce you to open source projects. One is called Apache SeaTunnel, and the other is, we call it Apache DolphinScheduler. Then we can go through some new concepts of DataOps, data mesh, and some new concepts. So this is the agenda. And actually now we meet some more and more requirements on BI team. We have a big data warehouse such as Teradata, and some people use Snowflake, and some people use Databricks, and some people use Hadoop in enterprise. Actually, we have separated data scheduling, integration, and data governance in different data warehouse or data mart. And there's are too many. We call it CDC, that's a change data capture, and batch data and the data stream in various of traditional and emergent data sources. So the data quality is very hard to control. And also, because we have many data sources in the data warehouse or data mart, not like DevOps, I think the development of the process in big data development is not very good handled. And also, there's many new data source and the data processing that we will have a spider web in our enterprise big data processing, and not like the old days. Now we have the users not only for the engineers, but also we have some people from sales department, product department, who want to use SQL or use other data analytic tools to use the data directly. So now we have many new requirements and new departments who want to use the big data platform. So this is the challenge of the big data team, I think. And so there's some new architecture. We call it EtLT. And in old days, we know ETL, that means extract data and transform and load into the data warehouse. And then big data comes. So for example, like a Hive or Spark or Delta Lake or Iceberg, we use some ELT architecture. That means we just extract the data from Oracle, from MySQL, and then load them into the Hive or to Snowflake. Then we do the transformation in Hive or in Snowflake. We didn't do some transform before the data warehouse. And now I think the situation are changed because we have many new data sources. For example, we have Oracle, we have SAP, and but also we have something like a MySQL or some database with a bin log. That means we can catch the database bin log and catch the data capture. Then we just transfer them into the data warehouse. And also we have some file on S3 or file on Google Cloud. And also we have some software API like SAP. And also we have SaaS. So for example, we have Salesforce, we have Workday, and we have other SaaS. So we just want to extract data and load into the data warehouse. And I think it's very difficult because the type and the form are not the same. So we have to do some normalization or some, we call little transformation before we just load them into the data warehouse. So there's a new architecture, we call it EtLT. That means we just extract data from a database, from a cloud database, and from a Kafka or from a SaaS. Then we do the normalization and do some filter and do some data cleaning, and then we load them into the data warehouse, such as a Snowflake or Trino or Hive or Peanut or ClickHouse. And then we just do the business transformation in the data warehouse. And then some data scientists can use the data in the AI. So I think there will be two different types of users. One type of user is called data engineering. That means we just prepare to do the data preparing. We just do the ETL, extract the data from different sources, and then load into the data warehouse. That's DataOps engineer or ETL developer or architect, their job. And some people, just like a sales analyst, product manager, or SQL developer, or AI scientist, they only use the data in the data warehouse. And they are used some tools like such as the dbt or something like that to do the transformation in business. So you can see that there are two types of users to use the EtLT architecture. And now we found that there are many new open source projects in modern data stacks. And we have data integration. Some people use Airbag in American, and the SeaTunnel in Apache Foundation, and Bitsu as in Japan, and DataX as in China, and RudderStack in Europe. These are all open source projects in data integration. And there's many data warehousing open source projects like Trino, which is called PrestoDB before, I think, and also ClickHouse and Peanut, Iceberg, Materialize, Doris, and many new data warehouse open source projects, because I think that the data is so big and the requirement want to be as soon as get the result as soon as possible. So you will have many user scenarios. So one kind of data warehouse will support one or two scenarios. So if you want to fulfill the whole requirements of a business department, perhaps you will have two or three kinds of data mart or data warehouse tools to support that. And then also we have transformation tools like Flink or dbt or Bean or Spark or Samantha. They're all open source projects. And also we have some orchestration tools like Airflow. I know many people use Airflow. And also there's a new project called DolphinScheduler, which is you can drag and drop to create a DEG, not only use a Python or XML to create a DEG. And there's another project called Flight. There's an open source project in American, which is focused on machine learning and AI ops. And also we have Dexter and Perfect. They're also open source projects. And also we have many other analysis tools like a Superset, eChart, Redash, Metabase, and V and Currybook. And now I know that AI is very hot. Actually, we have many AI open source projects like PyTorch, Ray, or Paddle, or Jupyter, or TensorFlow, or Mansport. Actually, there's many AI open source projects. So I think one enterprise can choose one or several open source projects in their big data enterprise. And I just gave you an example for the big data architecture in DataOps in your enterprise. Actually, we know that we will process the data in two ways. One way we call it real-time data processing. That means we just collect data from your IoT devices, or you collect the data from your database like MySQL or Oracle. We just do the CDC would change data capture into from your database, or we just catch a log, or we just extract the data from SAS or ERP or CRM in real-time way. So then you can use a SeaTunnel to get the data, collect data in real time, and you just can load data into Kafka or into your real-time OLAP engine, such like ClickHouse or Redshift, directly from your real-time data log, or you just send them into your SAS or some alert services. So this is we call it real-time data processing. And we have another ways of data processing. We call it batch data processing. You just can handle the data from file or message queue or database or cloud database or NoSQL database. Then you can just extract data by using a SQL-like language, and then you can just load the data into your data lake, like such like Hoodie, Hive, or Iceberg. And there's a feature we call it schema evolution. That means, we sometimes the data source will change the table columns. For example, we add some attribute or delete some attribute. In old days, we have to stop the whole ETL session, and then we change the target database, and then we change the ETL program, and then we start the whole things again. Now we have some new features we call a schema evolution. Not only SeaTunnel, but also other synchronized open source synchronized tools have this feature. That means you needn't to stop all the ETL process. You just now ETL tools have the feature that it can alter the target database by when the original database changed. So you needn't to stop all the process. They will do it automatically. And then you can use the SeaTunnel or other integration tools from your data lake to data warehouse. Then you can synchronize the data from data warehouse to OLAP. And also we call it reverse ETL. That means you can load the data, extract data from your data lake or from your data warehouse back into your SaaS or software or your transaction database. So there's many connectors in SeaTunnel and other synchronization data tools. And we see there's a little dolphin here. That means you can use a DolphinScheduler or Airflow to control the whole process, no matter you are in real-time data process or in batch data process. Now, also you can use the DolphinScheduler to control the AI or PyTorch or do some MOps operations. So this is some, we call it enterprise EtLT and orchestration example for the DataOps. Now we just, I want to introduce you these two open source projects because I think it's very interesting because it's very new to all of us. So one is we call the Apache SeaTunnel, and this is open source projects, and you just can extract data from many data sources, and it can load the data to many data target. And now it has more than 100 connectors. I think it's powerful, and just we use this project in our production environment. And I think it's a save time for us to do a lot of such as do the connector things, because we have a Kafka, we have a MySQL, we have a Elasticsearch, and we want to load them into Hive and then into the ClickHouse. So I needed to write the connectors. I just use the SeaTunnel and then the type of SQL-like program, then they can run it automatically. So now it's amazing that I found that SeaTunnel can support many data sources, not only the cloud, but also some on-prem open source projects, and also some SaaS, and also some file systems. So it's very easy for us to use SeaTunnel to synchronize data from different data sources. And I think it's easy to deploy, because the first time I just deployed SeaTunnel by one server, and I needed to deploy HDFS or Flink or Spark or something like that. I think it's very easy to use. And now I think the performance is very good, because I just use one server to synchronize data about 0.3 million records in 1 second. So it can fulfill my requirement. And now it supports many data sources. And the code is very good. It's very easy to use, because it's just like a SQL-like code. I needed to learn to use Scala, or let my engineer to type a lot of Python code. So it's very good for us, especially for the data analyst to do the similar code. And it supports CDC. That means real-time processing, and also the batch data processing in one program. So it's very easy for us to change from MySQL CDC to MySQL to batch, from MySQL to Hive, and also support multi-table synchronization. So I think there's many features, and I think it's just like a highway between different data sources. And so the architecture of a SeaTunnel is, I think, is very easy to understand, because it only has a source. That means you can extract data from many data sources, and it has a module called a sink. That means you can load data into many data sources. And there is we call it a transform. Transform part, that means you can do some normalization, or to filter some data from source to your target. And I think it's not data processing tools, because I found that SeaTunnel cannot support join or group by. I think it's a synchronization tools. It's not a data processing tools, but it can support really fast from different data source to the other data sources. So here is just an example from one data source to the other data sources. This is, you just use the password and name, and do some, and you can define your data sources, and then use some SQLite transformation. Then you have your sync part like this. Your sync part, for example, this is console. That means you just read the data from the source, and then there's no transform part, and then you can print the whole data in your console. So it's we can do it like this. So I think it's easy for us, because IoTDB is I think it's another Apache project that it is only a database for IoT devices. So there are many different data types. Then we can load the data from IoTDB to console or IoTDB to MySQL or to Hive. We needed to transform the data type by myself. SeaTunnel can do the data type transformation. So I think it is easy for us to synchronize data from different data sources. It really helps. And there's many open source use case. I think actually we learned this information from Shopee. This is a Singapore company, and ByteDance is TikTok, and it also uses a SeaTunnel, and I noticed that JP Morgan is using SeaTunnel, and I think there's many use cases for SeaTunnel. So for the SeaTunnel history, I think this open source project is open source in 2017, and now I think it's top level Apache projects, and now I think they will support schema evolution and the table creation, and the star is over 5,000. So I think it's a very good open source projects. And actually, in our company we use Apache SeaTunnel as a tool to synchronize data from different data sources, and it really helps. And also here are some website and also GitHub for SeaTunnel. And also there's I want to introduce another orchestration tools we call Apache DolphinScheduler. Actually, I just used Azkaban before, and there's many orchestration tools. For example, Linux cron tab. Actually, perhaps when we are a very little company, we just use the Linux cron tab to handle the shell, and the shell can handle the Hive or EMR or something like that. And then we found that it's not very good for us because it not will have the trigger and dependency. We cannot control the DAG. And then we use Azkaban. And also some people use Apache Airflow. I think it's very good, but it's very hard for us especially for the data analyst department, because the data analyst can write SQL, and they want to get a report every day, and they only can write SQL. They cannot write Python or write XML. We just give them some template of XML for Azkaban, but I think they're doing not very well. So the whole DAG is just like a spider web in our company. So what we want is to find some tools that can let our data analyst or data scientist to create the DAG very easily. Then we found DolphinScheduler. DolphinScheduler, I think, is very useful because it can not only DolphinScheduler can support Python to create a DAG, but DolphinScheduler can support use a drag and a drop to create a DAG. So I think it's very easy to use for our data analyst. And also, I think it said it's data decentralized design, and there's many use cases tell us that the performance and the stability is very good. So we just tried DolphinScheduler, and before that we just find that DolphinScheduler is open source more than 4 years, and now it says it's more than 3,000 active users, and I see that the star is over 10,000 in GitHub. So I think it's a very good open source project. But in China, it's very popular, but I think it's not very popular in Europe and in US. And so I want to introduce this project to all of us, to all of you. So I think the DolphinScheduler architecture is very good because it's written in Java, and it designed on architecture called multi-master and multi-worker. And I just used Hadoop before. We all know that Hadoop have a name node, right? name node is called one is called standby and one is active. So I think there's a bottleneck for Hadoop, because if you are many small tables, the name node will out of memory, it will own. So I think DolphinScheduler architecture is very good because it's designed multi-master and multi-worker. That means I think master server is just like the name node, and the worker server is just like the Hadoop worker server. So the master server is there's many master servers. So there will no bottleneck on the job on the handling the whole job. So I think it's a very good architecture, and yeah, that's like I say, it's very easy to use. You can just drag and drop to create a DAG, and now it said it can support that you can put this DAG into GitHub, and then you can to trigger the whole DevOps process. I think it's very good for us to use the DAG for the data analyst and the data scientist, because we cannot let them write a very good Python or XML code for the DAG, but I can let them to drag and drop a very good DAG. Then we can use this DAG in our production environment. And also, I think there's many new features in 3.1 version, and I'm using the old version, and I think the old version is very good because it's simple, and it said it's what you see and what you get workflow, and it's very easy for the data analyst to do to write the SQL and to create a workflow themselves. And also the reliability is very good, and also it has many workflow functions. For example, there's a task called dependent. That means one task can depend on another project's task, where you can depend on another project's another workflow in the other projects. So, and that really help in our production environment. And also it supports Spark, Have, MapReduce, and also Python, Shell, EMR, and S3, some jobs. And also it supports Kubernetes very well. So we can use operator on Kubernetes and combine DolphinScheduler to work together. And I'm not tried the newest version, but I think the feature is very good. For example, it said it supports machine learning orchestration. It supports SageMaker in AWS, and the DVC, and Jupyter, and PyTorch. So I think my data scientist team will be excited that they can prepare data by drag and drop, and just they can use the machine learning process in DolphinScheduler. And also in 3.1 version, they support real-time process. For example, Flink or Spark streaming, and also they support that kind of real-time process in DAG. So I think it's very interesting, because in old days we just use the batch job. You mean you know that one job is finished, and the other will trigger the other task. And for real-time task, I think it's very interesting, because in DAG there will be a virtual task in DAG map, and then that task will running all the time. So and you can depend on this task for the batch, and the real time. If the real time task failed, then the batch time who depends on this real-time task will also fail. So it's very interesting logic in this. And also it supports more Python YAML workflow to generate a new DAG, and also support Kubernetes. So now we use 2.0 and 2.1, 0.9 version of Dolphin Scheduler, but I think some new features are very attractive. So actually, we just do some comparison before we use Azkaban and Airflow and the Dolphin Scheduler, and there's many different directions we just compare. For example, stability and easy to use, and the extensibility, and also we just compare some features. There's some good on Airflow, and then some good on Azkaban, and some good on Dolphin Scheduler. And actually, we just choose Dolphin Scheduler because it can just light not only my engineers teams, but also my scientist teams and data analyst team, especially some data analysts not in my department, but in the business department. They can use the Dolphin Scheduler very easily, and I needed to train them to use Airflow or Azkaban. So that's why we use the Dolphin Scheduler. So, and there's many users, I think, in Dolphin Scheduler, and there's some typical use case which is a copy in the Dolphin Scheduler meetup, and this is very interesting because it says in China Unicom, Dolphin Scheduler can handle more than 1 million tasks in one Dolphin Scheduler cluster. So that's very it's amazing, because I know China Unicom is very big, because it's the second biggest telecom company in China. So the task of China Unicom big data platform is very big. So it's more than 1 million tasks, and China Unicom have more than 73 servers of Dolphin Scheduler. I think it's a very big cluster of Dolphin Scheduler, because in my company I only have three servers of Dolphin Scheduler, and China Unicom has many more servers. And also Shane, I think, is used Dolphin Scheduler. Shane, I think, is very popular not only in China but also popular all over the world. And Shane just migrated the whole workflow from Airflow to Dolphin Scheduler, because I think that they are the same requirements like me. Because Shane's data analysis team is in Indonesia, and I think their data analytic team is not very good at Python or XML. So they just migrate from Airflow to Dolphin, and I just migrated from Azkaban to Dolphin Scheduler, because of there's many business users who want to create their jobs on the big data platforms. So also Shopee and McDonald's, and there's another Chinese company use Dolphin Scheduler because of the easy use for the data analytic team. And also some company use Dolphin Scheduler as their data scientist platform, such as this LiGFM, and this is another security company in China. And I think it's very interesting, because Dolphin Scheduler has a feature, we call it sub-process. That means you can create a learning, a machine learning cycle by using different open source machine learning projects. For example, you can use SageMaker and PyTorch in one workflow, and then you can use this workflow as another task in another workflow. So it's very easy for data scientists to do the data preparation. And I think that's why LiGFM and 360 are using Dolphin Scheduler as their data scientist platform. So there's also, because it's open source, and you can download the whole code, or you can just use the Docker or something on website. I think it's free, and the Slack channel is it's very hard. You can use something. If you want to read some articles, you can use the Medium. You can visit Medium, this channel called DolphinScheduler. And in the last part, actually, I want to share you some DataOps concept, because I know DataOps is very hot in China and in America. And we know there's many ops actually in the, for example, DevOps, and many people in security call it SecOps or GitOps, and NetOps and ITOps. And actually, I think what is DataOps? DataOps is something that you have to control the whole data process from generate data, and then the data will go to the OLAP system and go to the ETL, into the data lake, and then perhaps something you have to build the machine learning or data model, and then predict data, and now you can use AI and ChatGPT to generate some new data. There's a cycle to do the whole things, and now we just define DataOps is not like a DevOps, because DevOps you just do something in software engineering. It will not control the process of data engineering and the data scientist, and especially for the data analyst. So I think the DataOps is to control the whole process from the development of the SQL and the integration code. Then you can control the whole process of engineering pipelines and the deployment, and also data versioning, and control the model versioning, and also you have to control the data analyst and static report or dashboard deployment. So I think it's not like a DevOps. I think DataOps is more complicated, because in this process you control not only the IT teams, not only the engineer teams, but also you have to control the process of a business department. For example, sometimes you want to define a report. Actually, this requirement of the report is not defined by the engineer, it's by the business department. And also, how to calculate this report is not that like a product manager to define this. It's always defined by the user department. And also sometimes there's a large communication and negotiation with the data engineering team. So I think it's more difficult to control the whole process in DataOps. So DevOps is, I think it's easier to control the process, because it's only control the development in software and the software engineering, but DataOps is more hard, I think. And also there's some new concept of which is related to DataOps. One we call it data fabric. I think is this is new concept which mentioned by I think perhaps it's IBM in just about 5 or 3 years ago, and then is popular in some data companies. And I think data fabric is something like we have to use the data by intelligent metadata. That means we have a data catalog in our enterprise, and we have intelligent metadata. That means we can find the data in the data marketplace, and business people needn't to know the details of the technical metadata or technical data. Where is the database? They only want to know is where is this KPI come from, and how to calculate it, and how, if I want to create a new KPI or new report, how can I create that kind of report, and which kind of data what kind of data we have. So this we call the data fabric. I think it's based on intelligent metadata. Then the whole system will face the data consumer directly. So this one concept, and I think it's very important to DataOps in data fabric, because you have to control the whole process, orchestration and the DataOps to control the whole process of data fabric. And also there's another concept we call the data mesh, and I think it's very popular, especially in American, because there's too many data sources and too many data warehouses. I know many people not only have Snowflake, but also have Teradata and Snowflake and the Delta Lake. In different department, they will choose different data house or data mart, and some people will use Presto and TrinoDB or Peanut or ClickHouse. And how to find the data in our enterprise. So data mesh, that means you just there's a layer we call the federated governance layer. That means you just collect the data, collect the metadata in this layer, and if the consumer visit your big data in your data marketplace, the federated governance will translate the SQL or translate the requirement to your different database, for example, Snowflake or to the Delta Lake. So for the final data consumers, they will not know you have many different data mart or data warehouse. They only know what we have, and they can visit the data. So the federated governance is very important in data mesh. And also DataOps is very important because you have to prepare the data, and also you have to collect data from the source system into your data lake or your data warehouse. Then control the whole data version and to do some set management in your data marketplace. So I think it is very popular for data mesh concept, and DataOps is also very important in this part. And also in America and in Europe, also in China, there's a very popular concept called a modern data stack, because there's many tools that because the data source, just like I mentioned, there's many data sources now, not only the SaaS, but also traditional software, and also cloud database, and now on-prem database. And hybrid cloud. There's many data sources. So we have to use a set of new data stack tools to do the ELT, or some people call the data ingestion, to ELT the data into the data warehouse. And I think it's very easy to use because you can choose several tools of the modern data stacks in the modern data stacks to fulfill your enterprise requirement, because different situation, the different requirements will let you to choose different tools in modern data stack. So I think it's a very new concept. In old days, we use Informatica, use Talent, or use IBM data stage to do the ETL things. Now we have many set of tools we can choose to do the modern data stack. And I think it's almost the end of my session. And this is my LinkedIn, and also you want to visit some projects I just introduced to you, you can use DolphinScheduler or SeaTunnel. And if you have some questions, and welcome to ask me. So thank you for listening, everyone.
Thank you, William. I have to say that You make it so easy to explain
any
the
questions?
very complex concepts. And I think it was really a very interesting presentation. Actually, I learned a lot. And also, I think your visualizations on how you make these complex schemas are quite simply explained. And I just posted on LinkedIn that I've never seen somebody explain the difference between ML ops, data ops, DevOps, and AI ops with such ease and such clarity. And I think the slides that you're using are absolutely excellent. So I was really impressed with your presentation. And I've been in big data for a long time, so thank you so much for presenting. I have a couple of questions, or I saw a couple of questions come in, so we still have a few minutes. First question is from Douglas. He's saying, I've heard about ETL and ELT, and now I saw EtLT. Is this something new?
Yes, because actually many people use ELT structure now because we extract data from data sources and load into Hive. But EtLT, that means you not only extract data from the transaction database. Now you have to extract data from a SaaS, from a cloud database, from a cloud file system, and perhaps you have to extract data from SAP in your hybrid cloud. So there will be a small t between before you just load the data into your data warehouse. So that's called EtLT, a small t to do the data normalization. For example, different data type from the SaaS or Kafka into your data warehouse, because it is not a structured data. So you have to do some normalization in small transformation. Then you can load them into your data warehouse, and this small transformation will transform the unstructured data into the structured data in your data warehouse. So that's what we call a small t.
Yeah, very good. Could I say that it's kind of data wrangling, but in between?
Yeah. Rendering and normalization.
Normalization. Yeah.
Normalization. Yeah.
Good. Yeah. Thanks so much. That's very clarifying. Another question that came in is from Shadia. Thanks so much. I didn't hear about Data Fabric before, and I needed to approve my PhD project. So I think that's a question, it's more of kind of like a comment. So I hope that really helps you with your PhD project. So that's good. Then the second question is also from the same person. So I'm going to go to that one first. Is, can I use this architecture to integrate machine learning with multi-agent systems?
Yeah. Actually, I think it's very good for machine learning or for a generic AI system, because you have to collect data from different data sources and then load the data to ChatGPT, right? So you have to prepare the data from different data sources. So that's why we call it EtLT, because you can just do a small t, and then you can transfer load the data to the GPT API. So I know somebody just do the GPT connector in SeaTunnel. And I think it'll be very interesting, because you can collect data from a Google Doc and your MySQL, and then let the GPT to know the data, and then you ask question in GPT. Yeah.
Good. I think that's an excellent point. Then another question. You have a lot of questions coming in. Next question is from Douglas. There seems to be plenty of options for data engineering solutions, but what are the key considerations when selecting the tools? I think that's an excellent question to ask.
Yes. Very good question. I think the first priority is the requirements of your company. For example, just like I mentioned, my company and Shane, the requirement of our company is how to use the big data easily. And some big company is not like that. So I have to, first is the requirement fulfill the requirement from our business department. Our business department want to build the SQL and build the process themselves. So I think the first is to fulfill the business requirement, and the second is the stability and the scalability. I think because we are a big data platform department, so I want to maintain the whole platform very easily, and then I don't want to handle a platform always have bugs. So I think the second is stability and scalability, and the third is some feature of this platform. So I think the first one is the business requirement. I think is very, very important for us.
Okay.
Yeah.
Very, very good. I have one last question, which is, I think, bit more of a comment. The question is from Shadia. Can we share the presentation? And for all the participants who are listening, on the right-hand side, you will see a button that says Handouts. And there you can download a PDF presentation of the slides that William just presented. So on the right-hand side, there is already a link towards the handouts for this session. So I hope that answers your question as well. I think a lot of people are going to be very interested in this slide deck, including myself. With that, William, I would like to thank you for what in my belief is an absolutely stunning and fantastic presentation. I'm a real content guy, so I really like it if people go in a little bit into depth around what these technical concepts are around. So thank you so much for sharing your time and your preparations with us. It's excellent to have you here today, and I hope I can invite you for next year already to wow us again with the wonderful world of open source and the Apache Software Foundation.
Okay, thank you, Jen, and thank you everyone for listening. Thank you.
Thank you so much. Good. For the rest, we are moving towards our next upcoming session. So in track number 2, there's already a workshop going on around generative AI with AWS. And on this side, we're going to go into a content session again. My next guest is going to be Laila Faridoun, who's the CEO and founder of Looking Forward Consultancy, and is going to talk about the role of big data analytics in enhancing organizational performance. Laila is a very gifted speaker. I shared the stage with her before, so make sure you don't miss this session as well. Look forward to seeing you back in 8 minutes. Thanks, everyone.